Hello everyone, welcome to the webinar this afternoon. We're just waiting for everybody to join. Just give them a few seconds. So this afternoon is the second in our series of webinars in association with the NPL, which we're really excited about. But before we get into that, I'll just give you a quick bit of background in case you don't already know about the Chartered Institute. You'll know if you've been to any of our webinars this year, we've been holding quite a lot of webinars, and we've got webinars which are targeted mostly for members, but we also have webinars that are targeted for a wider audience, so our innovation webinars and these ones in association with NPL. We have a whole bunch of content available on the website. We have a Pulse magazine, and sort of our remit is here to sort of help shape the profession and support organisations with their development of security professionals. So yes, that's a bit about the Chartered Institute. Obviously visit the website if you want to learn more about becoming a member. And just to say some housekeeping about today's webinar, all of you attending will be muted, but if you would like to ask questions, please do. You can use the Q&A section, which is at the bottom of your screen. Just pop your question in there at any time during the presentation, and then we'll get to those at the end of the session. And if you're having any problems during the session, just pop an email to support@CIISec.org and we'll be able to help you. So on that, I will hand over to our commentator, Kevin, who will introduce our speaker.
Good afternoon and welcome everybody, and thank you, Shona. And been delighted to introduce this series of webinars with NPL. And you probably know NPL best as sort of somewhere that does measurement or looks after the time signal, but actually NPL has had a huge history in cyber and just in information security in general. And some of the great advances in information security started at NPL. And it's one of the hidden gems of the technology world in the UK. And I actually started my career in information security as a student intern at NPL many years ago. So great to be hosting this series. Last month, we had Neil Stansford from NPL to just introduce this series, and delighted to be welcoming today Stuart Kitney. Stuart's the head of data science at NPL, and Stuart's had lots of experience working with startups, science research, and really looking forward to seeing what he's got to say to us this afternoon. As we go through the webinar, please ask any questions, and I'll be coming back. If you put them into the Q&A window, I'll be coming back at the end of the presentation, and we'll have a Q&A session with Stuart. So thank you very much, Stuart, for joining us. Really looking forward to what you've got to present, and over to you.
Thank you very much, Kevin, and welcome everybody, and thank you very much for this opportunity to present. So let me just share my screen, and then we can get underway. So I hope. Is the screen, is the slides visible? Good stuff. Right, let's kick into presentation mode. So yeah, as Kevin introduced me, I'm Stuart Kitney. I'm head of Department for Data Science and more recently Skills and Training as well. And I think what I've realised recently is how much of a skills component there is to what NPL is looking to achieve as an NMI moving forward in the future. And what I'd like to do is just move through a number of slides that give you a flavour for what we are doing as an organisation. I think Kevin's given a really good introduction as to the history and what NPL has done in the past around information and cybersecurity. And I think NPL has morphed and changed a fair bit in the last couple of decades. And I think we've sort of reinvigorated what we're trying to do around data science, particularly with a focus around data quality, data curation, and trustworthy AI and explainable AI. So I'm going to move on to my first slide. And the data science department at NPL is fairly new. So it was born out of a workshop that took place in Cambridge in 2016, the end of 2016, and it was a very international focused workshop. So it wasn't just national, it had contribution from NIST, so NPL's counterpart in the US, and more broadly afield from other members of the European Metrology Network. And historically, NPL had always been doing analytics and modeling in some shape or form through a number of groups within the organization, but there would be a specific domain specialism and focus. So you may find individuals in the materials group that may be looking at composites, for example. But this workshop really highlighted a number of areas that was thought and believed that NPL could really bring something different and a unique aspect to data science. And 13 key areas were highlighted as the role that a National Measurement Institute could play in understanding and addressing some industry challenges, because I think Neil will have done a very good job of explaining NPL's role as an application and a challenge-led organization that is very much trying to address industry and societal challenges. So we are very much an applied organization. So we do some fundamental research, but very much looking to apply that. These are the 13 key areas, and I think there'll be a lot of them that will resonate with people on this webinar, and there'll be some understanding of the challenges that are faced. But if you boil it down, what it really come down to is 4 key areas that NPL should focus on, and then bringing that metrology or the science of measurement to data. So it was trusting data, algorithms and software. It was merging multiple and disparate data sources, work around storage, curation and reuse of data, and support for decision making. So the department was created, as I say, 4 years ago. We've grown rapidly. So I had the pleasure to take on the head of department role in May 2019. And we've already grown in the last 2 years from 15 to 40 individuals. That includes joint appointments with our associated universities. So we're growing rapidly, but there's lots to do. So what I'm going to present in the following slides is just some of the work that we're doing around validation, standardization, particularly around data quality and data curation. But what's changed in the 4 years that we were formed as a department? And I think the reality is that there's even more of a global significance of digital and data. And these are some of the key areas that we are focusing on and looking to address, and some of the tools that we're trying to apply to meet these challenges. Now, I've highlighted the future border one in particular because I think it will speak to this audience, particularly given Brexit and the challenges of world trade and logistics and security of trading across borders and how you would digitize that. But there's information security aspects to all of these areas that we are working in. Now, we work in sector strategies. And so, for example, aging society will be addressed under our digital health program. And I will wrap up at the end of the presentation, giving an overview of some of the fantastic work that's been taking place in digital health. But one of the key points I would like to make is that I think since the inception of the department, the understanding of digital and data from a metrology perspective has become ever more prevalent and more of a requirement for us to be addressing. We work across the whole organization because the reality is as we move towards becoming a digital NMI, the work that we are doing to underpin that is key to all areas. So how are we structured? What does data science in 2020 look like? So we use the phrase data intensive metrology, and we have 2 key areas of focus, modeling and analytics. And there are some key themes and topics in there that I imagine that you will quite regularly recognize, whether it's working with high dimensional data sets, inference, optimization and sampling, uncertainty quantification is absolute key underpinning of what we do as an organization. Sparse compressed sensing, sensor networks, and particularly understanding the placement and validation of sensor networks and the validity of the data that they're generating. I'm very much moving into the area of trusted algorithms, particularly from a machine learning perspective for the application of AI. Very much from a life critical perspective as well. I'd like to really emphasize that. So we have work in digital health that would be looking to apply AI for decision making, but you've got to be able to ensure that that in a life critical situation that can be trusted. And assured autonomy is another area in particular that we are developing some key capability. And I think you will hear in January in the third webinar around some of the areas that we're working on in that field. We have a second area, which is data provenance and standards. And this very much speaks to what I'm going to cover more broadly in this presentation. And this very much comes back to those key principles that were picked out from that workshop that we held in Cambridge. And it's provenance, it's data quality indicators, and then it's using the tools that are available to us to be able to ensure that we can do that. So it's potentially using things like DLT and understanding aspects of data security. So why is measurement important? I think the reality is, as we move from the physical world to the cyber world, we have to have a key understanding of how we are bridging between physical and cyber worlds. So historically, NPL for 120 years has been a National Metrology Institute and has a fantastic understanding of the physical aspect of measurement. But how is that transferred into the cyber or the physical world when you begin to use things like digital twins? You try to start to represent things in a virtual world to save on additional measurements and reduce down the number of measurements that need to be taken physically. And so you have to have trust in the data that is generated. And that is very dependent on the measurement system that created it. And that's where this comes right back to the core capability of NPL. It's the understanding of that measurement that is key to how you then apply the skills and the knowledge and the tools of data science to that data creation. So we use this phrase, confidence in data. It can mean more efficient design, test and manufacture cycles, greater efficiencies in creation and delivery of data, leading to fewer mistakes, and all of the benefits of productivity that can bring. But what does confidence actually mean? And what do we mean when we say confidence in the terms of our roles in NMI? Well, it comes in three key areas. And I think I've touched on these briefly in the previous slides, but it's very much around understanding how good measurement underpins how that data was created. It's in knowing enough about the measurement conditions to know that the data is suitable for your application, and then you're not using some measurement modality that is redundant or actually doesn't generate the measurement that is required or the data that's required. And it's understanding the effect of any processing that has been done to the data post-measurement. And if you can understand the uncertainty within all of these aspects, and then you can propagate or measure that through and quantify it, then you've got a better opportunity to be able to have confidence in the decisions that have been made using that data. I think we all have seen recently some of the challenges around data related to COVID and questioning of where the figures have come from, what processing has been done, the latency and fidelity of the data. So I think this is just as much of a pressing issue than it's ever been. And we focus on three key aspects. So it's uncertainty, quantification and propagation, provenance of the data and the associated metadata, and trusted algorithms and software. So we use a particular diagram to explain this in more detail, just to give some context. So it's the data life cycle. And as a department that sits within the digital sector strategy of NPL, we very much use the collect, connect, comprehend cycle to explain more detail what we mean by confidence in data. So as you collect data through sensor systems, many modalities coming together to that data stream, you have to have an understanding of what that measurement system has been, how it's been captured. The data is then transmitted in some shape or form through a particular connection or medium, and it's understanding latency and the effect that that can have on missing data sets, the security of that information that is being transferred. The information is then stored in what format. Is all of it kept? What's the associated metadata to that gives you an indication of the quality of the data, its provenance. And then we move through to what you do with that data. So we've collected it, we've connected it in some shape or form through a network or through some storage medium. and then we move into comprehending the data. And this is where fusion comes in, or processing, post-processing. It's understanding the impact and effect that that can have on the data. And then we're at this analysis as a decision making, and you may introduce machine learning, AI, neural networks, and these will all have an impact on that provenance of the data. That is for a linear system, so you can imagine how much more complicated it gets when there are additional data inputs or we go through repeat cycles. And for that reason, that's why the uncertainty propagation is even more relevant and important, because that allows traceability back to that original measurement. So we have 3 key areas that we focus on within data science, but actually more broadly across NPL, because actually many of the projects that we're involved in at the moment are very much data capture and data focused. So it comes down to validation and standards for sensors and data capture and the uncertainty quantification, validation standards for data curation, and then validation and standards for weighting algorithms, explainable, trustworthy AI. That all leads to standards with measurable traceability and uncertainty quantification that supports regulation for the 4th industrial revolution. So this 4th industrial revolution is very much a term and phrase used to talk about digitization of industry. And we are well connected and working with the national quality infrastructure, so with BSI and UCAS and other partners, to try to understand what agile regulation looks like in a digital world. So I just wanted to move on now to some specific examples. So I've given you an overview of what data science at NPL is, what it looks like, what we're trying to achieve. So now I want to break down some examples of what we mean by the particular areas that we're working in and the standards that we are trying to generate and create and help get adopted so that we can validate this data. So I've termed this current state of scientific data curation, but I'm going to pose a challenge here that everybody on this call probably sees some of the same challenges in any data curation in any field. And the reality is that lots of data is captured frequently in changing and proprietary formats. It's not easily shareable or interoperable. Closed data formats that are controlled by vendors. Not much consensus in instrument and sample metadata recorded alongside the measurement. And data archaeology instead of data mining. So they're very much a case of we collect everything and it will be of some use in the future, and we'll be able to drop in and out of those data sets, those data lakes, and actually extract value. The reality is, if the data is not in a fit and proper form, that's very, very difficult and very wasteful. So we're very much working alongside the line to the FAIR principles, findable, accessible, interoperable, and reusable. And I liken it to what is metadata, and a really simple and easy description is you've got 2 tin cans and you think in the can is beans, and then when you open it up, it's spaghetti hoops, because there's no label on it. So you've got no way of knowing what the content was inside that set, that data set. Whereas metadata is the label on the tin, gives you much more information, is associated to what is the content within that set of that system. So what are we doing to make data fair? So there's the 4 key aspects of FAIR principles. So it's structured and standardized metadata. And I think as a national lab and as part of the worldwide NMI community, we have a role to play here in particular domains where there is no standardization of metadata. It's making sure that the data is accessible through aspects of machine readable data through particular techniques like XML, JSON. I've got an example that I'm going to present in a few slides around digital calibration certificates that will expand a bit more on that. It's using technologies and techniques such as graph databases and ontologies to make sure the data is interoperable. And then it's using tools that can extract and reuse that data, particularly when it's large data sets and it's just not viable for the human readable aspect to be able to do that. So it's machine learning and AI approaches. So I just quickly wanted to touch on what an ontology is. So there's the W3C definition. And this is some of the great work that we're doing within NPL. So it's just a screenshot of how we're trying to simulate the machine interpretable description of things. so that this information, once collected, has got the structure behind it that is underpinned by the aspects of standardized metadata that can then be used and full value extracted out of it. And one thing that I would like to flag and highlight is that from an information security aspect, having the associated metadata and the structured ontologies very much were built upon the specific dictionary databases that you use for particular fields. Very much allows the provenance of the data to be better understood and much more extractable, and therefore inherently improving the security of that information flow. So this is just an XML schema that has got the reference ontologies built in, speaking to specific defined attributes with accepted values from an original controlled dictionary that has been structured by the team working in this particular area. And this was light sheet microscopy as an example. So these are some of the underpinning areas that we're working in, and just a more visual snapshot of what that looks like. So this is the microscopy ontology example. So we've got user-defined controlled dictionaries that have been created at the domain-specific level. We structured a formal ontology, and then we're doing some great work developing a user interface for experiment annotation. So this transmits and transfers that information to a much more accessible and easy process. So what does that look like as a picture for a particular lab? And how are we automating this and structuring that metadata? So this is some great work that's taking place in one of the mass spec imaging labs at NPL that is funded by Cancer Research UK. And what this is doing is bringing together the aspects of standardization around metadata, using custom web form access to structure and capture that ontology information, to build a system on the NPL object store that is Hitachi Pento offering that allows us to be able to generate automated metadata and data, which can bring significant improvements through automated reporting, standardization, reproducibility of science, because it builds that evidence chain for who's done what and when, what conditions, that allows that standardized approach that really speaks to the role that we're trying to play as an NMI. And one key point here that I'd really like to emphasize is that it also really does improve and enhance the information flow and security through that life cycle and the provenance of the data. So I'm going to move now on to some specific examples of why this relates directly to our role as an NMI, and particularly around the international system of units. So we're in effect the UK custodian as the SI. Now this poses a challenge if we're trying to move towards digitization. So we're building some of the foundations through metadata and the ontologies through specific domain areas, but actually if we're going to create a digital SI, one of the challenges we've got to get to grips with is how you do that, how you use those base quantities, the derived units, and how they can be transferred into language that enables a digital SI. So we're part of a community that's looking to solve this problem. So one of the projects that we are currently working on is the SmartCom project in collaboration with the Euromet community. So this is an NPL funded, or European funded project that has got a number of key metrology institute partners, PTB and NPL being two of the significant ones that are working together to try to address this issue. And this is a real application of the area of the work that we have been doing within NPL. So this document is freely available on Zenodo, so please feel free to access it and read some of the challenges and some of the great work that we are doing. But delivering a digital SI is all about having those data formats that are structured, that I've presented previously, making sure that they're machine readable, that they comply by standards, and that any new standards that are developed and then disseminated through the international community. There are other ways of doing this. We're very much focused in XML at the moment, JSON and a few others, but I think if you look at the documentation, you'll see some of the great work that's been done on this project, but some of the challenges. So that's an application that's very much international focused in terms of trying to address a challenge. But within NPL, we're also mindful of new and different ways of building a measurement uncertainty network, or being able to deliver the calibration certificates in particular, but that digital SI through potentially things like blockchain or DLT. So we've done a small piece of work using the Ethereum open source blockchain platform, where we are looking at the opportunity to be able to distribute among nodes, have that cross-platform efficient working, cross-vendor, so it's not dependent on one particular vendor being a blockage in a chain. This very much speaks to being able to automate traceability and verification of other operations. It comes with the data set and because of the structured approach that you can take through the distributed ledger, that you can then be the custodian of the information that is generated through the calibration. This is a new way of focusing on measurement uncertainty and a measurement uncertainty networks. It's early stages, but this is one aspect of delivering what the digital SI would be. And a different and a distributed way of doing it. And the whole idea of this is that this very much speaks to being able to do in situ dynamic calibrations, or it speaks to being able to offer the digital SI at the point of need. So no longer would we be in a position where we would be dependent on equipment being sent to NPL for calibration or for traceability to the SI. We would be in a position where we can be much more external focused, or working at the point of need, building on all of the efficiencies and the productivity gains that you would generate from that. So this creates a future vision, and this is what it looks like. It's digital metrology, and how this could be a cloud-based approach, and what digital metrology could be a key enabler to. I've covered a number of these aspects in the previous slides, but it's very much built on FAIR principles, being able to enable reproducible science with full traceability, removing errors created due to manual data entry and manipulation, making sure that data is machine readable and actionable, producing digital calibration certificates through secure communications and networks. And there's some really exciting work taking place within the 5G and the comms group of NPL that is very much focused around what secure communications looks like in the digital world. So we're very much working in collaboration with them. And on the back of that, you'll begin to use things like digital twins that can remove some of the necessity for physical measurement, and you can move that into the virtual world. But to be able to do that, you've got to have confidence that that model of the twin is generating information and data that is trustworthy. It will open up the route to new science, particularly in industrial partners that have got easier access to the SI through Metrology Cloud. And we're also looking at smart digital Internet of Things and network sensors, and the standards needed to be embedded and developed within that field. So this all comes back to being able to provide a digital online cloud for NPL customers, and that traceability back to what the future of the SI looks like, and what a digital and what an NMI should be in the future. So they're just some slides of the areas or the specifics of what we're working in, but I just wanted to flag our work in digital health. And this is one slide that gives a snapshot of all of the areas that we're working in, and combines the working of provenance and standards with analytics and modeling. The website has just gone live for digital health, so I would really encourage you to take a look at that. There's some fantastic work going on there, and this really does come back to that understanding of the measurement modality, particularly as we move into a world where wearables become the go-to method of capturing health data. And we've got to be very careful and confident that that data that is collected is robust, is reproducible, and is validated in some shape or form. So when the slides are shared, please feel free to access the website, because it'll give a very good overview of some of the fantastic work that is taking place in digital health and how we're applying the techniques and methods that we're developing. My final slide is just to say that how are we communicating and disseminating this knowledge? It's done through a number of means. I've already mentioned we're part of an international community. Our core NMI role is to define how we process and use measurement data. We're doing that through good practice guides, input into standards, but we're also growing a particular area of skills and training. So the bottom right of this slide shows the machine learning training that has just been placed upon the Ingenuity platform. It's a very basic introduction to machine learning, but on the back of that, we are building in additional training material that will really give an understanding of uncertainty quantification applied to machine learning and how that can propagate errors through a system. And so we really do see ourselves as having a key role in terms of being able to train and upskill the UK industry and economy to be able to have a better understanding of data, the challenges around metrology for data science. So thank you very much. I'm very happy to now take questions and comments, and look forward to discussing any of the questions you have.
Great, thank you very much, Stuart, and very interesting presentation. And I guess I'd want to start somewhere relatively controversial to say it's great to see the application of standardization of data and data models, and you can see the benefits in the health industry, you can see the benefits about sharing scientific research, but for a lot of commercial organizations, their commercial value comes from protecting that data structure and not sharing it. How do you see those worlds coming together? Because it's great work that NPL is doing. How can we take this into application in a commercial context?
That's a really good question, Kevin. So I'll give you a very good example: digitally enabled supply chain. So pick an industry that you can imagine. So the automotive, there would be much more efficiency and value created through collaboration in that industry. So supply chains, sharing that information. There isn't really the driver to do that. And I think at this moment in time, because of commercial sensitivity. So we're very much working on the basis open as possible, closed as necessary type approach in the partnerships that we're developing and working in. But it is a challenge. I think some industries will be quicker and better at adopting the approach that sees the value in the data. So there's a collective benefit to be gained from the data being shared. And I think if we can find working examples in industry to highlight that everybody's better through the collective sharing of the data, then I think we can encourage an adoption to that more open mindset. But it is a challenge in particular areas. I do agree with that.
Yeah, I guess there's a privacy concern as well about wanting to share data in some contexts. That it's great to have all this data, but actually some of it you just don't want to have available. You've got restrictions with things like DPA where you can't share the data. So
agreed. And in life sciences in particular, the way that we've managed that challenge is by very much building collaboration and partnerships through clinicians, trusts, where we can get access to anonymized data, for example, and still do some of the tools and techniques on it, but don't compromise the closed nature of the data or the confidential nature of it. And I think that's a route for working as well.
Just say to everyone on the call, if there's questions, then please put them into the Q&A box, and I'll work my way through them from there. And I guess what I'd also like to go back to is the traceability. You talked at the beginning, and Neil talked a lot last month about traceability of data. that's really important. But obviously, if you're collecting vast amounts of data, how do you make sure that it's all traceable when you're processing so much volume of data? And you want to keep it secure, and you want to keep it private. There's a lot of challenges in there.
There is. And I think that comes back to the curation aspect of the work that we are doing, and working on the basis that through the automated data capture approach that we are taking, it's not about capture, it's not about storing or everything. It's being able to associate and decide what the value is in the data, making sure that that even if it's just the metadata that's captured, that's got the traceability, that then can be used to point back to the additional data sets. So particularly when it's large, complex data, then often the route to solving that problem is through association of the metadata and the traceability of that.
So using the metadata model to manage everything, to oversee everything. Great.
And there's probably a challenge to be addressed around the volume of data that is collected and whether it all does have the value that we believe it does. There's very much the approach at the moment. We see it fairly regularly of, well, it's just this data lake approach. It'll all get thrown somewhere and it's got value and we can retrieve it at a future date. I'm not sure that's the sensible approach longer term.
Yeah. And I think this is one of the really good things I see NPL always doing, is looking long term at things that everyone's looking short term about. Yes, we can capture lots of data, but what do we do with it in 20 or 30 years time?
Yeah.
Can we still use it? Does it have value? So some of the questions. So next question, will NPL's work help lead to greater accuracy for data, primarily in regard to wearable health devices?
So in regards to accuracy of data in the clinical field, yes, particularly when there's the traceability already in existence. So I can think of a number of areas where there's already standardized or standards in place, or there's already work done where NPL will calibrate particular pieces of equipment that you would find in a hospital. And there's the provenance there. When it comes to wearables, I think that's a different question altogether. And I think that will be very much on the basis of that it may not improve the accuracy, but it will be able to give you a confidence in the value of that data that is being generated and collected. I think the quality of the sensor systems that are used in wearables is very varied. I think we've often heard stories of challenges faced on the quality of data or the accuracy of measurement, and I think the work that we're doing will be very much more focused on being able to drive confidence in making decisions on the data captured from wearables, and it as much to be able to challenge maybe using them as the go-to tool for particular diagnosis. I think it will allow us to be able to say, well, realistically, do you have the confidence that is the correct decision to be making? And maybe it should be followed up with particular medical interventions or checkups rather than seeing wearables as the solution to all of the problems.
And we're as far as saying, well, wearables from this manufacturer have a certain sensitivity and from another a different sensitivity. So actually, look, here's the metadata that's saying actually you should treat this in a higher category.
Exactly. I think it'll be able to give that scale of approach of confidence rather than being able to say that everything should be trusted. Yeah, I think we're very much going to be on some sort of scale of quality.
So this is how much do you trust the data that is coming from your IoT devices?
Yes.
So that's a very interesting point. Another question: how can industry interact with the machine learning knowledge and expertise that NPL are acquiring?
I'm very happy for someone to contact me. My email address is on the final slide. Please reach out. We're developing material all of the time, so I really would welcome anybody that's interested in discussing that in more detail. Please do contact me and reach out.
And are there any particular areas of application you're looking at beyond, say, blockchain, healthcare? are there any particular focus areas that NPL is looking at the moment, or is it just primarily just proof of concept at the moment?
Some is proof of concept, but there are other areas that are a bit more advanced. I would say that the healthcare area is the particular one where a lot of a lot of the work has taken place recently. But we are also focused in assured autonomy, or trusted autonomous systems is an area of work and an area of focus. Definitely in terms of factory of the future. So what is the factory of the future, and how would you apply these tools in the factory? And I think they all pose different challenges around the training, because you can imagine in a factory, it's very much the approach as long as there's a go or no go light approach on a factory floor. Is that suitable, and is that enough? Whereas if you're thinking of an assured, an autonomous vehicle, whether it be land, air or sea, I think there's a very different approach to those two. Yeah. And I think you'll hear more in the webinar in January, actually, as to some of the great work we're doing around assured autonomy. Yeah. That'll give you a flavour and an indication of the work that we're doing.
Yeah. No, sounds really good. Okay, I think we've got to the end of the questions that come in. So, any last questions from anyone? No, I'm not seeing any more. So, yeah, last chance. I think in that case, thank you, Stuart. That's a really interesting subject area, and it's great to start getting down into the details of thinking about what is all this data that we're collecting. How do we handle it? Not just it's data for data's sake, but actually how can we bring it together? It's certainly a theme I've been seeing more of recently. Is so we've got this data, but how do we correlate it all together? How do we make sense out of it? How do we know how to trust it? So really interesting area. So I'd say thank you very much, Stuart. Great presentation. Thank you for the answering some of the questions afterwards. And Shona, I think it's back to you.
Thank you. Yes, thank you, Kevin. And Stuart, thanks ever so much. That was really fascinating. Yeah, really enjoyed that. So just to say thanks everyone for joining us today. Thanks to Stuart, obviously, for presenting, and Kevin for comparing. As you can see on the screen, we haven't finished for the year yet, and we're even got some dates lined up for next year for you. So as Stuart mentioned, the next one in the series with NPL is on the 19th of January, and that's all about assured autonomy. So you can sign up either via our LinkedIn page or on the website as well. But you can also see we've got our next masterclass event on the 9th of December, which is tomorrow. And that's predominantly for members. And then the next two in the ADP series. So plenty to look out for. We've got our live event coming up next year as well, and you can read more about that on the website. So pop over to the website, pop over to LinkedIn, check out all of our events, and don't forget to sign up. And on that note, have a good rest of your day, and thanks very much for joining.
Great. Thanks very much, everybody. Thank you, Stuart.
Thank you. Thank you.